Hi children, welcome to Maths class. Hope you are all waiting for Maths class because we started with a new chapter. Before that, let's have a good thought. Challenges are what make life interesting. Overcoming them is what makes life meaningful. Now we are undergoing the challenges of pandemic, being at home and studying. It's a very big challenge for all. But we started overcoming them and we are making it meaningful. And we have completed periodic assessment 1 and 2. And soon you are going to have your term 1 examination. So take over this challenge, overcome it and make it a meaningful and successful one. Okay children? Okay, let us begin the class just revising what we learned. So in previous class we started with surface and curves. Curves are of two types, simple curve and not a simple curve. In simple curve we have two types, open curves and closed curves. Similarly in not simple also we have open and closed curves. Difference between simple and non-simple curve is there won't be any intersection in a simple curve, whereas in not a simple curve we have intersection. It is not a simple curve. We have intersection points. Okay. Then what else we see there? Yes, we defined what is a polygon. A simple closed curve. It should be a simple one. There should not be any intersection between the curves and it should be a closed one. And that curve should be made up of only line segment. Such a figure is called as polygon. Then we defined what is diagonal. Diagonal is a line segment connecting two consecutive vertices of a polygon. You know what is two consecutive vertices. Hope you remember that. Then interior and exterior of a polygons. We classified the types of polygons like triangle, quadrilateral, pentagon, hexagon, septagon, octagon, nonagon, decagon. Isn't it? Okay, then we'll define convex and concave polygons. These convex and concave polygons are new to you, my dear children. And I hope you remember. Okay, how did we define convex and concave polygons? Using the term diagonal. Where do the diagonal lie in a concave polygon? Yes, at least one of the diagonal will lie outside the polygon. Such a polygon is called as concave polygons. The polygons in which at least one diagonal lies outside the polygon is called as concave polygons. It will have a shape of a cave bent inside, but we cannot use those words in a proper definition. Okay, all the other polygons which we learn regularly are convex polygons. Then what are the two different types of polygons? Regular and irregular polygons. This regular and irregular regular polygon is defined as using two words. What are those? Equiangular and equilateral. All the angles should be equal and all sides should be equal. If angles are equal and sides are not equal, even then it is not a regular polygon. It comes under the category of irregular polygon. Then we started with the property. The sum of all the angles in a quadrilateral is 360 degree. And I asked you to have a drawing in a paper, quadrilateral shape paper, and I asked you to tear and make it into 4 pieces and rearrange it so you will get a 360 degree. If you sum up all the angles. And we are going to have a different proof today. Let me show you how we got that 360. Here is a quadrilateral ABCD and I consider a point P in it. Yes, this is the point P and I join all the vertices A with P, B with P, C and D. All has been joined and we get so many angles like 1, 2, this bit part. 1, 2, 3, 4. These are all the numbers I gave for angle and it doesn't mean that the measure is 6, measure is 7. Hope you will not misunderstand like that. And here the name at the center or near the point P at the vertex P is X, Y, Z and W. Now I am going to find what is X. by angle sum property of a triangle. I am taking this triangle P, A and B, this triangle alone. In that, I can say x is equal to 180 minus angle 3 and angle 2. Isn't it? If I add all these three, I should get 180 degree. So, how to find x? From 180, I should subtract angle 3 and angle 2. See, that's the first statement I have written here. Similarly, you can write angle y, angle z and angle w. If I add x, y, z and w, I get 360. How? Yes, it is the center angle. If I add up whole, center angle is 360 degree. One rotation, complete rotation in making a circle. Yes, it is a 360 degree. So I wrote x plus y plus z is equal to 360 degree. If I add all these 180, 180, 184, 180, I get 720. Then all the minus signs, I took it out. So I have 1, 2, 3, 4, 5, 6, 7, 8. All the 8 angles are there here. So I clubbed everything inside a bracket with a common minus outside. Then I shift transposed all these angles to left hand side. Instead of writing again angle 1, angle 2, etc., I wrote sum of all the angles. Will you all agree? Sum of all the angles in the vertices. This angle 1 at the vertex we have. Angle 2 is also at the vertex A. So that's why I wrote sum of all the angles, which is equal to this 720 as it is, and this 360 gets transposed with a minus sign, minus 360. And 720 minus 360 is 360. That's how we say that all the angles, if I add up the angles in the quadrilateral alone, it is 360 degree. Okay. Now, here is a quadrilateral. Do you all agree this is a quadrilateral? Yes. 1, 2, 3 and 4 sides are there. It's a quadrilateral. It is a special quadrilateral. It is a concave quadrilateral because it has bent inside and one of the diagonal. See, consecutive vertex for A is D and B. So, it can have a diagonal joining A and C. So, it's lying outside. So, it is a concave quadrilateral. Do this quadrilateral also satisfy the angle sum property? Yes, it also satisfies, but you should be very clear in taking the angle. This is the angle that you should consider and not the angle that is outside the quadrilateral. Here it will be something like 200 above. It is a reflex angle above 180 degree. It will be above 180 degree. And you will add 1, 2, 3. This is third angle. And this is fourth angle. If you add all these 4 angles, you will get sum to be 360 degree. Is it clear? Now here is an example for you. We have to find the values of x. Is it a quadrilateral? Yes. I can name it as A, B, C, D, E. Is it a quadrilateral then? Check. 1, 2, 3, 4, 5. I have 5 sides. Okay. Now before discussing this angles, I will tell you something about other polygons. Okay. To start with, angle sum property of a triangle. If I add all the 3 angles, it is 180 degree. In quadrilateral, I said if I add all the angles, it is going to be 360. Isn't it? Another way of getting it is, I can divide this whole quadrilateral into 2 triangles. Here, one triangle, the other half of the triangle of the quadrilateral is again a triangle. The sum of all the angles in this triangle is 180. Here 180 and here also sum of all the angles is 180 degree. Isn't it? See, this bit and this bit together only we will have this whole angle. Half of the angle goes to this triangle, half of the angle goes to this triangle. So on the whole, if I add all the angles now, it becomes the angle of a quadrilateral. So I can say 2 times 180. If the sides are 4 in number, 4 minus 2 is 2. So I can generalize. See now here if I have 5 sides, 1, 2, 3, 4, 5. How many triangles I have? 1, 2, 3 triangles I have. So 3 into 180. How did I get 3? Number of side minus 2. Here also I subtracted 2. Isn't it? See that what I have written here in the last 4 minus 2. Here 5 minus 2. So when I talk about the polygon which has 6 sides, 1, 2, 3, 4, 5, 6. We have 6 sides. How many triangles I have? 1, 2, 3, 4. So how did I get 4? 6 minus 2. Isn't it? So in general I can say whatever may be the number of sides, I can say the sum of angles in that polygon, not a quadrilateral. I am talking about polygon now. Polygon in the sense it can have any number of sides. Quadrilateral in the sense it's a type of a polygon which has only 4 sides. So I can write n minus 2 into 180 degree. This is the general form of sum of angles in a polygon which has n sides. If it has 10 sides, in the place of n you will have 10. If it has 20 side polygon, in the place of n you will have 20. Yes, we can have polygons with 20 sides also. It will almost look like a circle. Okay. So let us discuss the problem that we started earlier. Here we have 5 sides. So I have to find the value of x. I know sum of all the angles is nothing but n minus 2 divided into 180. That is the sum of the angles, isn't it? This is the formula that we have learned. Here what will be the angle? It's fully 180 degree. So this one will become 110. What will be this angle? Yes, it is going to be 120. Only then 120 plus 60, 180 degree. Here 110, here 120. I have found 3 angles here. I have to find 4th and 5th angle. And we know if I add all these angles now, it is going to be n minus 2, 5 minus 2, 3. 3 into 180. What is 3 into 180? Come on, do it in your rough note. I will have 2x here along with this 30 plus 110 plus 120. 3 into 180. Come on, say me 3 into 180. 8 3s are 24. 2, 3, 5, 40. Isn't it? Here I will have what are all the triangles? 30, 110 and 120. Add these 3 angles now. 200, 230, 260. I will subtract that 260 now. Now it's a linear equation. Hope you will complete it. So you will have 2x is equal to 540 minus 260. You will get an answer. Divide it by 2 and you will get the final answer. I repeat again, my dear children. All the sum in this pentagon is going to be equal to 540. In pentagon, sum of angle is 540. In quadrilateral, sum of the angle is 360. In triangle, the sum of angle is 180 degree. Hope you understood how we got this 540. It is from this n minus 2 into 180. Okay. This is n minus 2. Okay, children. Let me move to the next question now. Here is one more question. See here, it's full of triangle alone. It's also again a polygon which has only 3 sides. Here I name this angle as angle R. By the angle sum property of a triangle, I can say R is equal to 180 minus 90 and minus 30. 90 plus 30 will be what? 120. So if I subtract 120, I will get angle A. So they have named it as angle A, not angle R. So angle A is equal to 180 minus 120 is equal to 60 degree. I have found this to be 60 degree. Then how to find the other angles? X. See here, it fully is called linear pair angles. It means the angles is equal to 180 degree. Sum of that angle is 180 degree. So I can say y is equal to 180 minus 60. See here, y is equal to 180 minus 60. Fully is 180. If I subtract the 60, I will get y. How about Z? Yes, 180 minus 30. Z is 180 minus 30. Without writing